Welcome to Natural Logarithms, section 11.6. Natural logarithms are very similar and in fact they have the same properties as common logarithms. The only difference between natural and common is a natural log is a base e. If you remember from section 3, we talked briefly about the number e. Number e is a number that we use that shows growth or decay. It's used in chemistry and things like that. It's also used in applications involving money, where you're growing or decaying money over time. So you'll be using the number e. So in this case, using natural logarithms, that's log to the e, or log base e of x, and we write it as ln instead of log. And you have that button on your calculator. And it's used for the natural log. Remember, the opposite of the natural log is the e to the x button, and that's on top of ln. And the opposite of the natural log is called the anti-logarithm, and that would be the e to the x button. Conversely, the opposite of logarithm for common logs would be 10 to the x, and notice that's above the log button, so that would be the anti-log. So we're looking at natural logs is log base e. So one other property to make sure you notice is anytime you see ln of e, that always equals 1, so that's going to help us out. So let's convert log base e to the 254. Anytime you see convert using natural logs, you're going to use the change of base formula from the previous section, section 5. So let's rewrite it using change of base. Log base e of 254 is going to equal, or I'm sorry, log base 6. I wrote that incorrectly from the book. Let's fix that first. Log base 6 of 254, so we're going to use natural logs. So it'll be log base e of 254 divided by log base e of 6. Same principle as before when we use the log button on the calculator. Now we use ln. So when you punch those two numbers in, the answer should be 3.0904. So that is the approximate answer for log base 6 of 254 using what? Base e, or natural logs. And remember, one last thing about this, we could also further rewrite this. If we have log base e, remember that's ln. So it would be ln of 254 over ln of 6. So there's your conversion. Let's go to the next one. Now we have a solve problem. 6.5 equals minus 16.25 ln of x. This one's going to involve the anti-logarithm, which is the e to the x button. So first we want to divide both sides by negative 16.25. We're trying to isolate the x by itself. So 6.5 divided by negative 16.25 is equal to ln of x. That number divided is negative 0.4, is equal to the natural log of x. And we use the anti-logarithm to get rid of the ln, or the natural log. So that would be the anti-ln of negative 0.4 is equal to x. And remember, the anti-ln is just e to the x on your calculator, so you have to hit the second button first. So for this, you would do second, and then the ln button, which is e to the x, and then negative 0.4. So x in this case is 0.67. Here's another problem using natural logarithms we need to solve. 3 to the 2x equals 7 to the x minus 1. We're going to set both sides equal to the natural log. Excuse me. 3 to the n, or excuse me, ln, the natural log of 3 to the 2x, is equal to the natural log of 7 to the x minus 1. Same property or principle applies when we have exponents. We move the exponents to the front. So 2x natural log of 3 is equal to x minus 1 natural log of 7. Now, natural log of 3 and natural log of 7 both have values. Natural log of 3 is 1.0986. Natural log of 7 is 1.9459. So now we need to distribute and continue to simplify. 2 times the 1.0986 on the left side would be 2.1972x. Then on the right side it would be 1.9459x minus 1.9459. Now we need to move the x to the left side, so we're going to subtract. These work the same way as if you had a whole number. So it would be 2.1972x minus 1.9459x equals negative 1.9459. So continuing to simplify, 2.2531x, excuse me, 2513x is equal to negative 1.9459. So we divide both sides by 0.2513, negative 7.7433 is your answer. So remember, the properties are the same as base 10 common logarithms, and we can use it to evaluate and solve expressions.